Hey everyone, we're going to take a look at a couple examples from solving quadratic inequalities. Check it out, 3a and b on page 368. So if we take a look at 3a here, we have a inequality and it is x squared minus 6x plus 10 greater than or equal to 2. The solution to this is going to look much bigger than what we have for equations in the past. There has been either two solutions, one solution, or no real solutions, in which case imaginary. With the inequality, we're going to have an infinite amount of solutions in an interval. So to solve this, we're going to use the test point method, and we are going to basically just make it into an equation at this point, and we're going to solve it just like it was an equation. So we have x squared minus 6x. If we set this equal to 0 and we move this 2 over, I'm going to have to subtract it from both sides, which is going to make this 10 into an 8. And then again, I'm making it into equation for now, so I'm going to set it equal to 0. And I want to solve this. So I can solve this here by factoring. So I'm going to factor this, and I'm going to find the two solutions. So if I factor this, I get x minus 2 and x minus 4, which means my two solutions are positive 2 and positive 4. Okay, these 2 points are going to be called my critical values. So I solve that to find my critical values. Okay. What I do now is I take those two critical values and I put them on a number line. So I'm going to make a number line. Well, it doesn't have to be a perfect number line, just a number line, and you're going to put the 2 points 2 and 4 on this number line from least on the left to greatest on the right. And I'm going to look up here for a moment, and I'm just going to take a look and see, do I have inclusion or not? What type of symbol am I working with up here? And it is a greater than or equal to symbol, so that means I'm going to color in my values at 2 and 4. So let's say there's my 2, there's my 4. Again, it doesn't have to be perfect. So here's my number line. The point 2 and the point 4 are going to be in my solution because of the inclusion up here. So now I'm going to test the regions in between and outside of the critical values. So let me check a value to the left of 2. So I'm going to check, let's say x equals 0. And I'm going to see if this part of the number line, when I put a number in less than 2, easiest one is 0, is that going to be true or false? So let's put a 0 in for x. So if I put a 0 up here in for x, that means I would have 0 squared minus 6 times 0, which is 0, plus 10. So basically it's 10 greater than or equal to 2. So when I put that x equals 0 into the original inequality, it was true. So what that tells me is that all the values less than 2 are part of my solution. So if I get another color here, my solution includes all of the values. Any value smaller than or equal to 2 will make this inequality true, including 2 because we have inclusion up here. Okay, let's take a look at a value in between 2 and 4, and the most obvious choice to check would be to x equals 3. So if I put 3 up here, I'm going to get 3 squared, which is 9. So let's keep track of this down here. 3 squared, which is 9, minus 6 times 3, which is minus 18, plus 10, and I'm checking to see if that's greater than or equal to 2. Alright, well, 9 plus 10 is 19, minus 18 is 1, so this is the same as saying, is 1 greater than or equal to 2? And that's not, that's false. So what that means is, my solution is not the values between 2 and 4. So those do not work. Alright, let's check a number greater than 4. So probably the most obvious choice then would be 5. Try to keep it as small as you can. So let's check x equals 5. If we square 5, we get 25, minus 6 times 5, which is 30, plus 10. And is that greater than or equal to 2? Well, this is 25 minus 30 is negative 5, plus 10 is 5. So is 5 greater than or equal to 2? That's true. So what we find here is that my solution is going to be anything less than or equal to 2, or anything greater than or equal to 4. So the last step is to write an inequality that represents this number line. And if it has a gap here, a space in between, that's called a disjunction, and you have to include or in your statement. Because there's no way it can be less than or equal to 2 and greater than or equal to 4. There's no way. So it's either less than or equal to 2 or it's greater than or equal to 4. So my inequality is written like this: x less than or equal to 2 or x greater than or equal to 4. So there you have, check it out, 3a. Alright, let's take a look at question 3b. So here we have the same type of problem. We want to set it equal to 0, so we want to get this 2 over to the other side. So we're going to subtract 2 from both sides. So if I get this 2 over to the other side, this 7 becomes a 5. Okay, and then I'm making it equal. I'm making an equation for now to find my critical values. So we have negative 2x squared plus 3x plus 5. And that is going to be factorable. So we're going to factor this. Okay, this is a little more difficult. My two first terms have to be 2x and x, and we'll figure out where the negative goes in a moment. And my last two terms have to be 5 and 1. And I want to get a difference of 3. So I'm going to group the 1 with the 2 and the 5 with the x on the inside. And I want my middle term to be positive 3, so that means I'm going to make this a negative 2x. Alright, if I just want to double check that I factored that right, I'll do my outside terms and my inside terms and just check. My outside terms give me a product of 2x, my inside terms give me a product of 5x. When I combine those two together, I do get my middle term of 3 positive 3x. Okay, so I can be sure that that's factored accurately. So now I'm going to find the critical values. Well, this one's really easy. This is negative 1. And this one is a fraction, so this is going to be, remember, the opposite of this over that. So negative 5 over negative 2 is going to be positive 5/2, which is 2 1/2. So there's my critical values. I'm going to take those two and I'm going to put them on a number line. So here's my number line. My smaller one goes first. So on the left hand side is going to be my -1. And it doesn't have to be perfect, again, just anywhere here. And on my positive side is going to be 2.5. And then we're going to test those regions. So here's -1. Here's 2.5. Let's pick a number smaller than -1. So let's check, x equals -2. So what happens when you put -2 in for x in the original? Okay, well, if you square -2, you get 4. And if you multiply 4 by -2, you get -8. Plus 3 times -2, well, that's -6. Plus 7. And we're looking to see if all that is less than 2. Okay, -14 plus 7 is -7, and -7 is certainly less than 2. So that is true. This is true out here. So if that's true, that means my solution includes all the values less than -1. So I'm going to draw an arrow indicating all the values less than -1. And in this case, not including. So I'm going to do a little erasing here. I'll have to redo this, but there's supposed to be an open circle, so I need to make sure that there's an open circle at the value -1. So this is an open circle, not a closed, not a colored in circle, which indicates that -1 is not part of my solution. So it's all values less than -1. Alright, let's check a value in between. So let's check a good value in between, which would be 0. So the 0 is probably the easiest to check. You put 0 in, that makes all this stuff 0. So is 7 less than 2? Nope, that's false. So again, it's not in between here. It's going to be on the outsides. Let me clean this up here a little bit. Open circle at 2.5. Now I just want to be sure, double check. If it's not on the inside, 9 times out of 10 it's on the outside, but we just want to be sure. So let's check for x equal to 3. So -2 times 3 squared, which is 9, that's -18. Plus 3 times 3, which is 9. Plus 7 is at less than 2. Oops, that's supposed to be a 7. Plus 7 is at less than 2. -18 plus 9 plus 7. Sorry, is that less than, okay, that's what I was, is it less than 2.5? I was saying, no, it's not less than, so it doesn't work, but it's actually -2 less than 2.5. So is -2 in fact less than 2.5? And of course it is. So this is also true. So I'm going to make an arrow that will go from 2.5 on out. So there we have our solution on the graph. And if we want to make a inequality, again, that's going to be an OR statement, a disjunction. So it's going to be any value less than -1. So x, any value x, less than -1, or any value x greater than 2.5. So there is, check it out, 3a and 3b.